Intel Parallel Studio has already shipped. Have you any comment about TBB versus PPL?
I do have some comments about TBB and PPL. So, if you pull up the last release of TBB, you'll see in the appendix, these are the pieces of the PPL that we implemented. So what we want to do is we want to show people one way to do things. We collaborated with big chunks of the PPL. If you open up the header files for concurrent vector and concurrent queue, you'll find that the interfaces are the same. You'll find that the semantics are the same. And you'll find that there's more than just Microsoft on copyright. Right? We collaborated on these. We really, really care about this. We know that if you're using C++, you're doing cross-platform development. That's one of the reasons why you're using it. And we don't want to confuse you. The market is not served well by teaching people multiple ways of doing things. Right? Here is how we think the best that we know how, a good way to do this. And so TBB is a wonderful product. The other thing we need to say about TBB, and they announced this at both of their IDFs for the last few years, they're actually building on the runtime. So if you have an application that's using the PPL and you have an application that's using TBB, and they haven't said exactly, TBB or MKL or OpenMP, they just said we want to collaborate here. That composability and that competition doesn't need to happen even if you're using libraries from different vendors. And that's incredibly important. So that's what I have to say about TBB.
The next question is about agent library.
About which?
Agent library.
Oh, the agents library.
Yeah.
Okay, great.
Sorry for my accent.
That's fine.
Have you any plan to extend it to communicate between agents over the network, like Axiom?
Have we? So to extend it cross-process and across the network. There's nothing, in all of the asynchronous message passing in the box is in process. I expect that over the next period of time, I don't know exactly when, because we provide these extras when we get around to these samples. I expect we'll be blogging about how to integrate agents, how to send a message, and then integrate with the facilities that Windows already has for community cross-processes and communicating across the network, how to actually send a message, keep the programming model the same. But the point of the message block and the point of the agents library is, here's a target that I send a message to. We have some built-in blocks. You can build your own. Okay. When you call send, when you build your own, when you derive your class from iSource and iTarget, and we are just in the process of putting up some blogs on that. I think they'll show up in the next couple of weeks. One may have already posted. When you do this, you can build your own message block. So if you want to build a message block that you send a message to it, and it does a cross-process communication with it, that's a so-called some of the more exciting things that we do in Windows 7. That's very doable. So.
Parallel development is easier with the new version, but it's still difficult for masses.
For what?
For masses.
Yes.
And have you any ideas on how to improve the parallel experience for masses?
This is the hard problem. How do we make it so this thing that's generally, when we talk to developers, and this happens in every country, they say we've got a handful of guys. They're our best guys. They're doing the concurrency work. Right? That's what they're saying today. And so what we want to enable, and Axiom is great about this. This is this .NET language because it's baked into the language. It's safe by default.
Yeah.
I can teach people how to use the message blocks and the agents in a model that is safer.
Yeah.
As long as you sort of follow constraints. And I showed that. So this is a very, very simple example, which how to sort of avoid message block. But to the extent that you can take some of these patterns, you can build an agent or an actor, which is what the agent is an implementation of. It's an implementation of the actor pattern. Communicate it through message blocks by sending messages, and have that message block now. All the operations on the message block are consistent, thread safe. They're synchronized. Right? I'm not going to say that you can't break this, but if I have an overwrite buffer, it's guaranteed to give you a copy of the latest thing that it has. If I link additional message blocks, you can link to them at dynamically across thread, and that's not going to break. Now you can still take the message type of that and still break that, but you're opting into the race conditions, and if you follow the guidance, it's a way that's safer. Parallel loops, there's some really beautiful things you can do with lambdas. This is one of the wonderful things in the C++ OX. There's a lot of debate. Do I capture, variables on the stack by reference, or do I capture them by value? My understanding is that there's a lot of really good reasons for both, and there are. So they decided to capture nothing by default, which is beautiful, because you can take this lambda, you can capture nothing, you can build it up, and you can compile it, and it's going to tell you every piece of state that you touch. And it's going to generate a compiler error. And then you can go look at every single piece of state and every variable and decide whether you're capturing that by value or whether you're capturing it by reference, or in some cases where you want to take a mutable and change the value. So that's something that the language is doing. It's a more subtle way. I know that we'll be doing more, and I hope that we're going to be doing more in future versions of Visual Studio. We also have some of the fuzz testing and some of the concurrency analysis tools to help there. I don't remember the name. That isn't chess. It's like the cousin to chess. It's Featherlight?
Yeah.
Right, so there's some things that we're doing in research that I believe are going to start using as well.
The next question is about GPU. There is some developer, a lot of developer, GPU developer, ask for hybrid solution to address CPU and GPU with the same API. Do you have any ideas or project inside Microsoft to do that?
Well, we did the accelerator project. I believe that's available on Microsoft Research for Demo. So that's something we're definitely exploring the space. Direct compute is a really big thing in DirectX 11. It's a way for you to actually program to DirectX like it. So that's really wonderful as well. But it's pretty early still for us to be thinking about this. But there are some things publicly that you can go look at and see.
Okay, Rick. Thank you very much. It was very good for us, and I hope to see you to the next PDC.
I hope so too.
Okay, thank you.
Thank you.